Hi guys, myself Manoj.M. In this video, we are going to discuss about the NOT gate. I am going to explain about the NOT gate in this session, guys. Okay, yeah, guys, let us write NOT gate here, and then symbol here. Okay, symbol. When the input is A, output is equal to A bar. Y is equal to A bar. NOT gate, guys. It's also known as inverter. Okay, guys, yeah, let us write the truth table here. Truth table A, Y, 0. Next, when the input is 1, what is the output? When the input is 0, output is 1. When the input is 1, the output is 0, guys. Okay, yeah, here we can write it as output will be invert of input. Okay, guys, yeah. Now let us discuss the applications of NOT gate. Okay, what are the applications of this NOT gate? Applications of NOT gate. Okay, I will change the color to blue. Okay, yeah. The first application we are going to discuss is NOT gate as ring oscillator. Okay, yeah. Let us write a circuit diagram of that. Here there is a odd number of inverters. Okay, that means the odd number of NOT gate. Okay, then connect from here to here. Okay, yeah. Why this is why? Yeah, there is a propagation delay between the gates that is represented as TPD. Okay, TPD, TPD, TPD. Okay, yeah. Here read this. Connect odd number of NOT gate. Okay, and the second one is their propagation delay. Yeah, let me move this side. Okay, their propagation delay TPD of each NOT gate. Okay, gate. Okay, that's it. Here, yeah, let us explain this part using the timing diagram. You are going to understand it. Yeah, let us write the timing diagram for this. Yeah, I read this. Yeah, let us explain this concept to you. I will change the color to green to explain this concept. Let us think the output we are here is 0. Okay, when it is 0, here it will be 0, right? Till TPD the output is 0. Okay, and then if it becomes 1, also the output is 0, then it will be 0 to 2 TPD, and then it will become 0, and the output is till now is 0, since it is also 0. That's it. Okay, and then it is 1, it will become 1, it will cancel out, and again then it will become 1, and then the output is 1. Okay, and here when the input is 1 in the second TPD, also the output is 1. Okay, for this, and then again it also will be 1. Okay, that's it. till 3 TPD it will be 0 and then till 3 PD it will 1 because I have seeing that TPD plus TPD plus TPD 3 TPD it will take its time as usual. How it becomes 0 till the point, that's it, that's like that. Okay, yeah, I will explain you again once. Yeah, let me erase this. I hope you will get clear cut understanding. Guys, I will again once. Guys, I will again explain this. When it will, when the this becomes 1 from this, the output is still 1. Okay, and then next period this will become 0 since it will become 1, since till now this become 1, and then it will become 1, the output is 1 since till now this becomes 1, and then the output passes to 0 and then it will go to 0. Okay, I hope you understand the concept. Yeah, okay, we know that the time period is to till 6 PD because it completes the one cycle at the place. Okay, time period is represented by T. Okay, yeah, let's T is equal to 6 TPD. Okay, we can write this also as how many inverters we use. That means how many NOT gates? 3 NOT gates, right? Let us write 2N TPD. N is number of NOT gate. Okay, that's it. And then we know that the frequency F is equal to 1 by T. That means 1 by 6 TPD. Okay, or 1 by 2N TPD. It is the general formula. It is for this particular, we use the 3 NOT gates. This is like the general formula. Okay, and then let us discuss the NOT gate as buffer. Okay, yeah, I will write it here. Second one, yeah, guys, yeah, let us write second one, NOT gate as buffer. Okay, that's it. Yeah, let us discuss this. Let us know what is buffer. Okay, buffer is simple. I will explain. When we give the input 0, output will be 0. Okay, when we give the input 1, output will be 1. Okay, let us write it in the statement form. If we give input 0, output will be 0. Okay, if we give input 1, output will be 1. Okay, that's it. That is the meaning of buffer. Let us consider this as buffer. Let me next realize using the NOT gate. This is the buffer. Here, here. Okay, let me change the color for the input and output. When the input is 0, the output will be 0. When the input is 1, the output will be 1. Okay, yeah, let us realize the buffer using the NOT gate. Two inverters simply, right? Okay, when the input is 0, then inverter pass through this, in one inverter it will become 1, then again pass through this inverter it will become 0. If the input is 1, when it passes through this first inverter it will become 0 and then again passes through the inverter it will become 1. Okay, I hope you understand how it works as a buffer NOT gate. Okay, and let's next discuss about the, yeah, now let's discuss about the NOT gate as a bistable multivibrator. Third one, NOT gate as bistable multivibrator. Okay, yeah, let us discuss about this. What does it mean by multivibrator? Yeah, multivibrator, the output will be steady. That means output does not changes till we change the input. That is the meaning of it. That means it will be in the steady state until we change the output. Yeah, let multi-vibrator output will be steady until we change the input. Okay, this is the meaning of the multi-vibrator. Yeah, let us explain this using the NOT gate. Here we use the two NOT gates. Okay, like this we are going to use this. Let it be. Why? Here the buffer and the bistable multivibrator are different. Okay, here there is a feedback. Here there is no feedback. Okay, let us give the output as 0 here. When it will become 0, this will become 0, this will become 1, this will be 0. Let us give 1 as the output. When 1 is the output, here it will become 1, here it will become 0. That's it, like that. Okay, yeah, here I will write what I explained there. Here also there is a propagation delay for each gate as TPD. Okay, connect even number of not gate. Okay, and there is a propagation delay. That's one why we need to write. There is a propagation delay TPD for each not gate. Okay, there is a propagation delay TPD for each not gate. I hope you understand the not gate used as a ring oscillator, not gate used as a buffer, not gate used as a bistable multivibrator. I hope you understand all the concepts and this truth table and this complete explanation. If you suggest something I need to do, you can suggest in the comment section. You can comment in the comment section. I will take the suggestion from you. That helps us to improve the quality of the content to provide to you. That will helps us also. I am asking so that if this video understandable to you, please hit the like button. If you didn't subscribe my channel, please subscribe my channel and press the bell icon, guys. Thank you for watching, guys.